What if I told you there are oceans out there so deep, you could take the Mariana Trench, multiply it by thousands, and still not reach the bottom? Oceans that make Earth's seas look like puddles in comparison. Welcome to the mind-bending reality of water worlds, planets that make our oceans seem like backyard swimming pools. Imagine an ocean that's not just deep, but so incredibly vast that it would completely submerge every continent on Earth 8 times over. That's not science fiction. That's what astronomers are finding orbiting distant stars. These aren't just watery planets, they're aquatic behemoths where the concept of a seabed becomes almost meaningless. The first confirmed water world was Kepler 22b, discovered in 2011 about 600 light-years away. But this was just the beginning. Scientists soon realized they were looking at an entirely new class of planet, one where water isn't just a surface feature, but the primary component of the entire world. The term water world specifically refers to planets that are up to 50% water by mass. To put that in perspective, Earth is only about 0.02% water by mass. That's like comparing a single droplet to an Olympic-sized swimming pool. These planets form differently than Earth, often in the outer, colder regions of solar systems where ice is abundant. When they migrate inward toward their stars, that ice melts into global oceans of unimaginable depth. The pressure at the bottom of these oceans would be crushing, literally millions of times greater than Earth's atmospheric pressure. Water at those pressures behaves in ways we can barely comprehend, forming exotic phases of ice that are denser than regular ice, creating what scientists call hot ice, or supersonic ice, that can conduct electricity while remaining solid. One of the most studied water worlds is GJ 1214b, located about 40 light-years away. This planet is often called a mini-Neptune, and its entire surface is likely covered by a global ocean that's hundreds of kilometers deep. For comparison, the average depth of Earth's oceans is about 3.7 kilometers. The Mariana Trench, our deepest point, goes down to about 11 kilometers. But on GJ 1214b, the ocean depth could easily exceed 500 kilometers. That's a water column so tall it would reach from the ground nearly to the International Space Station if it were on Earth. The sheer weight of all that water creates pressures so intense that the water at the bottom isn't even recognizable as the liquid we know. It forms what's called ice VII, a crystalline form of water that remains solid even at temperatures that would normally boil water, all because of the unimaginable pressure. Even more extreme is Kepler 62e and Kepler 62f, siblings in a planetary system about 1,200 light-years away. These are potentially completely covered by water with no land masses whatsoever. Imagine sailing across an endless ocean where the nearest shore is literally the other side of the planet. The weather patterns on these worlds would be spectacular, with continent-sized hurricanes and waves that could dwarf anything we've ever seen on Earth. But here's where it gets really interesting: the search for life. Water is essential for life as we know it, so these water worlds seem like perfect candidates. However, there's a catch. Deep oceans without land masses might lack the mineral diversity that fueled Earth's evolutionary processes. But scientists speculate that life could evolve around hydrothermal vents on the ocean floor, similar to how life thrives around deep-sea vents in our own oceans. The real question is, what kind of life could survive under pressures that would instantly crush any submarine we've ever built? Could there be pressure-resistant organisms swimming in these alien seas? The detection methods for these planets are fascinating too. Scientists use the transit method, watching for the tiny dip in a star's brightness when a planet passes in front of it. By analyzing how much light is blocked and how the star's spectrum changes, they can estimate the planet's size and composition. Water worlds have distinct atmospheric signatures that give away their watery nature. The James Webb Space Telescope is now taking this research to the next level, analyzing the atmospheres of these distant worlds with unprecedented precision. What's truly staggering is the scale. Some estimates suggest that water worlds might be one of the most common planet types in our galaxy. Just think about that. There could be billions of planets across the Milky Way with oceans deeper than anything we can imagine. Oceans that contain more water than exists on Earth by orders of magnitude. The water content of a single large water world could exceed all the water in our solar system combined. The implications are profound. If life is common in the universe, these water worlds could be teeming with it. They represent an entirely different path that planetary evolution can take, one where water dominates everything. As we discover more of these aquatic planets, we're forced to reconsider what makes a planet habitable and what forms life might take in environments we can barely comprehend. The oceans of these distant worlds represent one of the most exciting frontiers in astronomy, promising answers to fundamental questions about our place in the cosmos and the diversity of worlds that exist beyond our solar system. Which of these water worlds would you most want to explore if we had the technology? Drop your answer in the comments and follow for more mind-blowing space discoveries.